Good morning. Am I audible?
Yes, sir.
Okay. So let us get started. Let me share the presentation. Is the presentation visible?
Yes, sir.
Okay. So, friends, good morning again. We are starting on a new module now, getting into some of the core issues in software engineering. So the first thing that I would like to discuss is what is being talked to you in the software engineering laboratory classes, often by Professor Abir and Professor Shwarangshu. That is software development life cycle. So it's like it's kind of modeled or conceived in terms of our human life cycle, where we are born and we grow up, get our education, and then we get married, have families, and we grow old, and then one day we pass off. So it's similar to that, but software can go through a lot of iterative part in the life cycle. So this there are different ways you can actually develop software, and therefore there are different life cycle models that are available. So they are collectively called the SDLC, or the software development life cycle. This is more or less a coverage which I think will take 2 or 3 lectures to cover. So as I started saying that SDLC stands for software development life cycle. It talks about the process for developing, designing, and maintaining software projects, of course, by ensuring all functionalities along with the user requirements, objectives, and goals, etc. So if you recall my very early discussion in module 1 about why software is a development process, it's not a construction process. It will relate to this software development life cycle issues that, in terms of software practices, we have not still been able to come to a stage where different development stages in the life cycle could have been firmly standardized, unlike many other core engineering like civil engineering or mechanical engineering and so on. So we keep on striving to achieve the overall quality and cost of the project. So we'll come to this diagram subsequently. So first, let us try to see what are the goals of a software development lifecycle. I mean, what are we trying to achieve? So I'll take one step backward and try to really ask ourselves as to what are the objectives of an organization, that is a company. What is the company looking for? Naturally, at a very top level, a company is trying to make money by fair and honest practices, by providing quality service to the customer. This is the general concept, or quality product to the customer. This is a general concept of a organizational objective. But if we drill it down a little bit, then we'll say that there are two primary objectives that organizations would try to strive for. One is efficiency. Efficiency is about build the system right. When you're building a system, it could be a product also. Then you should build it right. That is, you know what to build, but in the process of building, you should make things right at every stage. Do things right is the main thing in efficiency, because if you don't, then you have to come back and really correct those, fix those, replace those, recall from the market, and everything means cost, everything means rework. So if we look into the build the system right perspective of efficiency, we can talk about two very well-known incidents in software industry. about 20 years back. I think it was early 90s, late 90s, when Windows 98, the then next version of Windows, which was highly talked of, were to be released, and Microsoft was totally geared up, and there was an international press conference which was called, where the then CEO Bill Gates was to launch it. And the unfortunate fact is, when he started the machine and started the launch, the Windows 98 crashed. So that created a lot of bad feeling about the company, about the stability of Windows as a base and all that. Microsoft had to spend really hundreds of millions to recover from that. So that is an example of not building a system right. What they were building, they knew it very well. The Windows were their priority system, their proprietary system, and they knew exactly what they want to do, but they did not do it right. So that is a loss of efficiency. On the other side, you can see that we have Windows 10, which most of us use, and happens to be the most popular OS right now. So it is a system, again, which Microsoft knew how to build, what to build, and they have built it right. In more specific software engineering terms, we'll say that efficiency is the lines of quality code produced per man hour. That if I input 1 man hour of effort, whether it is in specification design or in development or in testing, the net number of lines of quality code that have been produced, if I divide by total manpower invested, man hour invested in that project, then that should be as high as possible. Similarly, it could be in terms of support. I mean, instances of quality support provided per man week should be very, very high. I mean, we all are now hearing heavily about quality of support from Airtel. You must have seen that ad, 0 complaints on Airtel system. So that's kind of a efficiency target that they're looking at. So the core of the thing is that how can you improve your efficiency? If you minimize rework, you make a mistake, you have to correct it. And the effort of that correction or the cost of that correction could be very, very high. In some cases, it could be just fixing a bug. In some cases, it could be, doing a redesign. In some cases, it could be doing a redistribution. In some cases, it could be recalling a product from the market. I mean, several instances are there for that. So that is what the organization is looking at. I'm talking about this because SDLC must strive to meet these objectives. The other objective, which is equally important and very critical, is effectiveness, which for several systems products are very important, that build the right system. See the difference from efficiency. In efficiency, we are saying that we know what system to build. You have to build it correctly, rightly. Here we are saying, do we know what system to build? Have we understood what system to build? Have we understood what the user actually needs? So building the right system is very important. Doing the right things are very important. For example, again, 2 examples. One, I'm not sure if you have heard about the Iridium project, which was spearheaded by Motorola. It was about providing satellite phone service all across the world. Every point on the world will have a phone service through satellite, and it was planned that every day one satellite will be, every day of the 365 days, one satellite will be thrown up in the air, and it will be able to spread over the whole of the globe, so that anybody would be able to connect to that satellite phone. So this was a very prestigious Iridium project, which unfortunately it was implemented perfectly well. I mean, it worked everywhere, and launches happened correctly. The phones worked from Arctic to Antarctic, everywhere, everything. But the project, disastrously failed because what was not known are the requirements. When the project was implemented, it was found that very few customers actually need a satellite phone, because all over the land, which is primarily inhabited, where where humans exist, the mobile phone service itself is pretty good enough. Satellite phone with its cost will not be able to compete with that. So who needs satellite phone heavily? Those who are on ships, and that too in the deep sea, those who are on very, very remote areas. So the customer base was really very small to support the enormous cost of putting up a satellite every day. It also failed because of the basic phone set. The phone set was about 4 kgs of weight. So it was pretty inconvenient to hold and talk in that phone set. So Iridium turned out to be one of the biggest bankruptcies in the history of engineering. So effectiveness failed. The right system was not built, though whatever was built rightly. The user requirements were not properly analyzed. Vis-a-vis, if you see another very mega scale project of Tesla, the electric vehicles. I'm sure all of you are very familiar with Elon Musk, who spearheaded this, which is a very high risk, high cost project. Excellent cars developed, though at times we are seeing certain failures, but very, very rarely. But that has been built, even with it is exorbitantly priced compared to the normal car. But still, it was positioned in the right market with right amount of versioning. The cost started coming down to a point where more and more customers are engaged and so on. So even though many people had the technology of electric vehicles, it is Tesla who finally could deliver the right system, the right electric vehicle. So building the right system is equally important. So both aspects are important, that you must know the system that you are building. You must build the right system which meets the user's requirements. At the same time, you must build it rightly. In terms of effectiveness, we typically measure it in terms of cost. That efficiency is quality code produced per man hour. Effectiveness is the quality code produced per dollar. Dollar by dollar, I mean currency. I mean, dollar is one of the universal currencies, but it could be rupees, it could be ruble, anything. So the less dollar you spend on producing a line of quality code, your effectiveness will be better. The cost for every instance of support has to be less. So again, it comes to minimizing the rework. You have to get right the first time itself. Whereas effectiveness has more to do with understanding the customer, having the customer with you to know that you are building the system that the customer really needs. Efficiency has to do more with the way you are doing the development, the way you are using your tools, the way you are doing your testing, and so on. Both of these are covered in terms of a set of software processes. A process is a way of doing things. So following right processes will ensure efficiency and effectiveness both. Right. So that is the importance of SDLC. The life cycle, software development life cycle, is a collection of best practices and processes which we must adopt appropriately so that we can increase the efficiency and effectiveness. So moving to next slide, SDLC is about process compliance. That is, you have processes, and SDLC has to ensure that you are following those processes in the right manner. So there are processes don't get followed by themselves. They will be followed if there are checks and balances. If there is a check to see that the process is followed. So compliance to process means several reviews have to happen, tests have to happen, and so on and so forth. So we will talk about all those over a period of time. So in short, SDLC has three primary goals. One is to ensure that high quality systems are delivered. Right. So that is the first goal of SDLC. Whatever you deliver has to be of high quality, ensuring high efficiency. Now, what is quality? I'll talk on a separate lecture on quality. Quality is actually a kind of the way we look at quality is not the formal notion of quality. I mean, you would very loosely say that, well, in terms of car, a car like Honda City is of a better quality than say Maruti Alto, or a BMW is better than Toyota Corolla. A Toyota Corolla is better in quality than Honda City, and so on. I mean, this is casually what we say, but that is not the right sense of quality. The way we use quality in this context actually means grade. These are different grades of product. The price at which Maruti Alto is available is way less than the price at which a Honda City car will be available, which is way, way less than the price of a BMW. So they are not to be compared for quality, they are to be compared for grade. They are different grades of product. You know that you are paying less and you get less, right? So quality is conformance to commitment. When you pay for a Maruti Alto, the company, Maruti Suzuki, tells you that this is what you will get. You will get, say, if you have taken an Alto, say K10, you'll get a 1000cc engine. You'll be able to run the AC when the car runs at 60 kilometers per hour. It will, in urban areas, it will give you a mileage per liter, kilometerage per liter of 12 kilometer. On highway, it will give you 16 kilometer, and so on and so forth. So it has made a certain set of commitments to you, and how far they comply with those commitments is the sense of quality. But Maruti Alto has not made this commitment that you will have a very smooth, jerk-free ride on a rough road. You go to Honda City, costs a lot more. It makes another set of commitments. It probably makes a smaller commitment in terms of fuel efficiency, but makes a much larger commitment in terms of comfort of travel, ease of driving, and so on and so forth. You go to BMW, it gives you even bigger, even higher safety, gives you higher comfort, and so on. And how far it complies to that is what is quality. So if unfortunately, if somebody's Maruti Alto crashes, then that poor person does not have airbag to save. But if same fate happens with the BMW, the airbag has to flow in and save that person. If it does not, then it is bad quality, right? So quality is about conformance to commitment, conformance to contract. So when you develop a software, I just took an example from the hard world of cars to make things more understandable for you. But when it comes to software, it's the same thing that you are talking of. You could have editors, which is a notepad, an editor which is a WordPad, editor which is a word processor, or you have Google Docs. Each one of them are of different grade, and in their grade they must satisfy the quality, whatever is committed for that. That is what is the first objective of SDLC. The second, the process should be such that there must be strong management control over the project at every stage. So I said that SDLC is about process compliance. If you have to do things right, if you have to do right things, then you need to follow processes, need to do things in a certain way which has been tested over time. How do you ensure that it will happen? Someone else, and that is what is represented by management. If you are a first level developer, then you will have a team lead who is your management point of contact. If you are a team lead, then you have a project lead who is your point of management control. If you're a project lead, you will have a project manager who is your point of management control, and so on. So that management control has to be enforced to oversee, to review, to ensure that compliances are happening, so that you can achieve efficiency, you can achieve effectiveness, you can certainly achieve process compliance, you can control cost, because you will maximize profit if you can keep cost under control. Otherwise, you will not make profit. And management control have to also look at What is the customer satisfaction? Are you doing things in the right way? Are you doing the right things? Everything. So there needs to be a strong management control in the SDLC model that we talk of. Third, but not the least, is maximize the productivity. Particularly in software, the major investment or major component of cost in software is actually the human brain, is the human resource. Bottom line, 70% to 75% of the cost of a software company goes in paying salary. Then comes the offices, infrastructure, all of that. But most of it is, I mean, you all are working hard here for a good package. And that package comes from the cost incurred to cover that CTC. So what the company has to ensure, what Google has to ensure, that you have maximum productivity. If you are paid certain X lakhs of CTC, then your productivity should guarantee that effectively you earn about 10 times of that. So, I mean, that's kind of, big companies have bigger ratios and so on, but a typical software development company becomes viable if you pay, say, 10 lakhs CTC every year to a human hand, a project person in your company, then the effective earning from that person has to be 10 times that, has to be at least 1 crore, right? So this will fall if the productivity of that person is less. If the person makes more and more errors and more rework has to happen because of that, you lose time, you lose deadlines, you lose money overall. So this maximization of productivity can be built by best practices, that you follow the best practices so that the possibility of making errors become less. So that is what we have been talking about in the earlier module when we talked about object-oriented design and all that. So these have been shown over hundreds of thousands of projects that software, object-oriented modeling and safe programming in languages and type safety and all those are practices which give you better quality at lesser cost. And that's what we are striving for. So that's all SDLC is all about. Right. So naturally, if you ensure those, then you will get the proper benefit. It will address the goals and problems so that the project is implemented successfully. Project members will not be able to proceed before completion and approval of the prior stage. From one stage to the other, you cannot go unless you have management approval. You need to have that management control. It has necessary checks at every stage. Checks and balances are most important. Project members can continue the software development process without incurring any complication. You have clarity of what you are doing. You know exactly what is to be done, so you don't spend a lot of time figuring out what you are doing and if you are doing things right. Optimal control with minimum problems is what SDLC will try to ensure you. Okay, having said that, let us look into the basic stages of SDLC. Now, we will look at subsequently at a different set of models, and every model will try to kind of engage this stage in one way or the other in a differently or similarly interconnected ways. So stages start at this blue top left corner, requirement gathering and analysis. First, you'll have to know the system you have to build. And as I talk, please keep on, mentally at least referring to at least assignment 3, which you have seen that text. I have at the very beginning given a specification, right? So that stage naturally has certain inputs which has to come from the customer. And the output of that stage is what I have given you there is a specification, right? What I need to build. Now, if you get it wrong at this point, if you're not building the right system, then everything else you do is not going to give you the desired product. Once you have the specification and you have analyzed those specifications, you will see this coming in the assignment 3 clearly. Then you go over the design as to how, if this kind of a system has to be there, how would you do it using your hardware, software, and so on, and multiple levels of that design. We'll get to these details a little bit more. Once the design outputs you a very details of what needs to be actually built, including the language to be used, the tools to be used, the testing to be used, the operating system to be used, the thread model to be used, and so on and so forth, all these details. Then you go into the meat of the whole thing, which all of us love, which is the development phase, which is actually, according to those design, you actually write the code, put them together, test them, and build up the system. Then comes the phase where you test. That is where, obviously, when you develop, you obviously test, but that's called a developer test. You are developing and you are testing. So it is, if you have made a mistake in understanding, your testing will also have that same mistake. So testing is a phase where almost always you engage certain automation and certain independent project team members who do not know how you have developed. They know the specification. They know what is needed. And they have got what you have developed. So they will test and tell you, okay, did you develop what was required? Right. Now, it may help in building the system right, but testing often may not help you in building the right system. If you have captured the requirements wrong, you still have a problem. Okay, so the output of testing stage would be a certain kind of system which everybody certifies, does what it is supposed to do, but you are still in the lab. You are still in your company. Then you go to the deployment. Then you go to the real field and install that, deploy that on the customer's environment, on the customer's machines, in terms of the customer's situation and so on. And that process of installation and deployment is a very, very tricky area, which, depending on how you have built and how you have tested, the deployment might go very smoothly, or it might need, further changes. You have to come back and so on. And then the system gets into live. So system goes live, that everybody starts using it. And as customers use it, they will come back and say, okay, there is a bug here, there's a bug there. So you get into the maintenance. And after in the life cycle, after maintenance has happened for a certain period of time, the customer might come back and tell you, okay, it was working fine. The net banking system that you had given us, the online banking system that you had given us, was working fine. But now government of India has changed. In the last budget, the government of India has changed certain tax rules. So now we have to report the interest earned on mutual fund every month, and actually credit that every month. Earlier, it used to be an annual disbursement. So we have to credit that every month. We have to deduct tax for that every month. We have to deposit that tax and get it reflected on 26A's tax form every month, and so on. So the specification changes. So they ask for a new version of the software, and you are back to square one. Again, you do the requirement analysis and so on, and you have a bigger problem now because you already have an existing system. You do not want to implement everything. When you are making changes for dividend disbursement for mutual fund, you certainly do not want to change the transaction system for savings bank accounts, right? So you want to keep them untouched, but the required things have to change. But certainly the reporting of tax earning, form 16A, has to change, which has the savings bank earning as well as your dividend interest earning and so on, right? So this is kind of, these are broadly the stages. So every stage you'll see is typically earmarked by typical inputs and outputs. So let's take a quick look. I've given you the overall. Let's take a quick look on the specific stages. So first, the requirements gathering and analysis phase, which has to happen. This is the most unstructured phase, because this has to happen through communication between stakeholders, end users, and project teams. Stakeholder is typically the customer who is paying for the project, right? But stakeholders could be more. Stakeholders could be partners of the customer. Stakeholders could be regulatories. For example, if you are doing a say a stock trading system, then your stakeholder is your stock exchange because they are the customer. But you will also have to take into account the the organizations like NSDL or CDSL, who are demat depositories of the shares, dematerialized depositories of your share. You have to take the registrar of companies in the loop so that you do not make a trading system which violates the company regulations and so on. So those are the stakeholders. You might want to include the end users. If you are making a personalized stock trading system like ICICI Direct or ShareKhan or something like that, end users are individuals like you and me. So you'd like to know what are the facilities that we would want. So this is on the user side, and then certainly the project team, your project managers, senior architects and so on has to engage into communication to understand the customer. The stakeholders might give you documentation on that. The documentation will often be incomplete. The documentation will be broken. There will not be enough information available. Often the customer may not be able to say what the customer needs. That's pretty much a very recurring problem, and the owners finally will come to you. So you'll have to be very careful. The customer will never accept that the customer has made a mistake. There's a golden rule in the industry. It is said customer is always correct. That's the mindset with which you have to work. The customer is always correct. Customer cannot make a mistake. So if the customer has made a mistake, it is the onus is on you. So the process has to be such that you gather those requirements from the customer through different processes of interviews, surveys, documentation, and so on. And while you gather them, you gather both the functional as well as non-functional requirements. Functional requirements is how it should operate. What are the functionalities? What kind of screens you'll have? What kind of interface will work? What kind of transaction rules are allowed, and so on for a stock trading system. But there could be non-functional in terms of what kind of browsers it should work on. Should it also be enabled for low form factor devices like mobile phones or tabs and so on? So there could be a number of non-functional requirements, both of which you'll have to gather together. And then you create what is called a product requirements document, typically called the SRS, software requirement specification. Professor Shorangshu has already shared with you a sample, overall sample of what all it should have. Or if you refer to assignment 3, you will see a very, very rudimentary form of a requirement specification where you say, okay, this is what I need. Right? Now, it is your responsibility to get things clarified from the customer to the best extent possible so that you create an SRS which is complete and sound. That is, it covers all questions that might come up. It covers all decisions that might need to be taken. And whatever you write is correct and consistent. Here you write one definition for senior citizen, and there you write a different definition for senior citizen. Here you say, okay, people, elder than 65 years is a senior citizen, and there you say people, male people more than 60 years of is a senior citizen, and females more than 58 years is senior citizen. This kind of inconsistency in the software requirement specification would be disastrous for the subsequent project phases. And you might create certain small prototypes to show to the customer as to what you have actually understood. So these are most critical requirement gathering and analysis phase. And just try to map this onto what you see in assignment 3 document. You'll soon get assignment 4 document also, which will have these kind of segments into it. Refer to what we are doing in the lab. It will follow these stages very structurally. Then you have a design phase, which you will do an architectural design. Right. Now, when you are doing things like assignment 3, it is so simple that your architecture is rudimentary, but often you will have multi-module, complex, interacting, distributed systems, and architectural design becomes a main issue. And mainstay in that is separation of requirements. What are your hardware system requirements, and what are your software system requirements? Because depending on that, your design will differ. Because for example, if you're using multi-threading, you got to know what kind of threading is available in the hardware on which this is targeted to be developed. If this is targeted to be developed on a say Google Pixel 2 mobile phone, you are having one kind of hardware. If it is targeted to be developed on a Lenovo laptop running i7, having i7, you have a different kind of hardware, right? So clarity of hardware and software system requirements are required in the design phase. Clarity of functional and non-functional requirements are required at this phase, which you'll have to document in the designed document. So designing the system architecture based on this gathered requirement in the SRAS is the mainstay here. And particularly for these two phases, the requirements capture and design phase, we will make use of another language tool, which has become very, very popular over the last 2 decades, I should say. It's called the Unified Modeling Language. I will talk about this in a separate module, which kind of is a diagram-based language where diagram, and it uses icons or diagram components which are well defined. So when you write the specification in English, what you meant and what I understand, there could be a big gap, right? The same thing read by 2 people are interpreted in their mental context. So unified modeling language helps solve this problem by using standardized diagrams, in which you are putting what you are trying to say. So the requirement specification will find out the use cases. What are the typical ways you will use it? Design will create class diagrams from that. What are the hierarchies that you will have? What are the kind of, so some of that I talked about loosely in the assignment 3 design part. What is a sequence diagram? That is, what is a sequence of events that you expect to happen? What are the activities that the system is designed for? So there are a variety of diagrams, several of them. Few are very important core of any system, which we will talk about in a different module. And with all these, you first create a high level design, which kind of says, okay, these are my this is my class diagram, these are my interfaces, and so on. And then you go on to the low level design, where you talk about specific instantiation methods. You identify specific consonants of objects. You talk about choice of data structures and algorithms and so on. So you specify all of those so that when you go to the next phase of development, you have every details clearly spelled out so that you don't make mistakes. Coming to the development phase, the codes have to be written. And what we have done, spent substantial amount of time in module 2, is to empower you for this design and development phase, so that you can make a good design, which is easy to code, which is, you can make good interfaces, which are easy to use correctly and difficult to use incorrectly, and so on. And in this phase, you write the actual code, you demonstrate the work, typically before business analysts. Companies typically have business analysts who are not supposed to know enough of development, but they understand the business. So they are kind of your internal customers. These are called internal customers. So they will tell you whether your development is going right, will ask for modification to the work. And along with this, you do unit testing. So again, you will recall in assignment 3, I talked about unit testing. I showed you some samples of unit testing and unit test plan for the fraction class. I mean, we will talk about unit testing and testing in general also as a separate module. But unit testing at least will make sure that whatever individually you are developing, the different components and modules are correct to the best extent of design specification that you have got and the design vehicle of language and tools that you have used. Then you go on to the testing phase. As I said, almost all stages of SDLC will involve a testing strategy. I mean, though we talk about testing more in the post development stage, but obviously you are doing unit testing during development. You might do some paper testing of model or prototype testing of the model in the design phase itself, or even in the requirements phase. So when we talk about SDLC's testing phase, we typically refer to checking, reporting, and fixing the system as a whole. So testing phase has a main part of system integration testing. So where you have 10 classes, you have put together everything of the class and so on, algorithms, everything. Now, if you put them together in the application, does it work well? So that's what the testing phase, and it usually in a typical system, this becomes a huge thing. You have to write separate test plans for that. Often there will be separate test teams for doing that. So it will engage in testing the system as a whole, perform different types of tests in the system. I will talk about in assignment 3, I talked about unit test and application test. There are different kinds of tests like directed test, random tests, your coverage tests, exhaustive test, and so on. So we'll talk about some of those in our testing module. And then you report these in form of bugs and defects, and it goes back to development and make the changes. And if you are unfortunate, it might go back to design. You might find that your design itself was faulty. This interface is faulty by design. If you are very, very unfortunate, it might go back to the requirements. You might discover that you are suddenly stuck here with a situation where you have a contradiction in the requirement specification itself, or things like that. Finally, you have the deployment and maintenance phase, where you are ready to launch to the customer. So often little bit medium to big systems are not released in one go. They're typically released to limited users by testing it in a real business environment. This is called UAT, or user acceptance testing, that you have given it to the user in her environment fully, and you tell her to test and report to you and accept that if things are going okay. So that ensures that now, of course, things may go wrong even after that, because user acceptance testing might happen for say a stock transactional system for 100 users, 200 users, but the live system may be using 20,000 users. So maybe your scalability of the system might fail. So there are problems that might happen after deployment as well. So you need to get into maintenance, but the deployment phase has its target of passing the user acceptance test. The system is ready for delivery, installed in the user environment. Errors are rectified that might have been missed previously, and you empower the system to become eligible to go inside the data center where it should reside. I mean, that's a very generic model that we are talking of, right? Okay, so before I proceed further, I would like to take you through this. This is a classical fun description on how things go wrong. In terms of these stages, you might see, okay, the stages are defined so well, it should all be okay, but you will understand why checks and balances are very important. So here is where the customer, in a very broad sense, possibly wanted a swing from a tree, something like that. So this is the first left top diagram is an iconization for how the customer explained it to your project team. But from this explanation, this is what the next diagram is what the project team understood. They understood that it should be of one plank and should be tied on both sides. And from that understanding of the SRS, when the analysis happened, this is how the analyst designed it, because analysts figured out that with the swing tied on both sides to the branches, it cannot swing. So it put extra support to hold the rest of the tree and cut this in the middle so that you can swing in the middle. And then finally, when the developer in the development phase actually wrote the code, this is how it turned out to be. And then the business consultant was there to check on your development, and the business consultant, being a businessman, did not think that it could just be a swing. It needs a sofa to be there, right? So there was a big gap on that. All of you looked for documentation, and this is how the project was documented. I mean, it does not exist. I mean, you just documented the shadow of the tree, but not the tree, not the swing. So that's typically how the documentation is typically broken. And finally, when you took the system and installed it, this is what you have. You have a rope hanging from the branch, and not the seat, and not even the other rope, and so on. And this is how the customer was built from time to time. These flags are milestones where customers were built high, and probably the customer paid, and so on. And finally, this is how you supported. When you could not make the swing work, you simply cut the tree off. Right? And finally, what remains a big question in a large number of software projects is, what did the customer actually need? Right? A very iconic representation. I love this diagram, so I wanted to share with you for a little bit of fun also. But this is, unfortunately, the true story in a majority of the software projects. And whole of SDLC is an attempt to avoid such kind of unfortunate things from happening. So before I get onto the models, let me just ask if there are questions. I understand at your level, many of the things I'm talking of might sound a little bit of Greek unfamiliar and kind of irrelevant, because you're still too much in the academic environment. You're too much into just study system. The reality is still far, but this is the reality that you are gearing up to. That's where the software engineering lies about. Any question, friends?
Sir?
Oh, yeah.
Sir, if like effective, like from the first slide where you're talking about the Microsoft thing, if efficiency is so much important, then why do companies tend to gravitate towards like really inefficient languages and practices?
Well, there are different reasons for that. One, not they do not gravitate to inefficient language, I should say. There are two things that happen. One is what you are saying inefficient may be efficient for the context in which they are used. But a majority of things happen because of a legacy. As we saw, and we'll see more of that this is a cyclical process, it's a life cycle. So suppose you developed a system with the state of the art in 1990s, and you used C for that because that was the language of choice, the most efficient language and most nice development language, and so on. Now in 2010, 20 years from there, when you are having to maintain that, it is not easy to move out of C and go to C++ and clean up a lot of the mess that you have. Many a times the customer will simply refuse to rewrite components, modules which do not have bugs, because they will say that the moment you rewrite, there will be bugs. So you get stuck with the inefficiency, not only of the language, of the platform. For example, we have had mainframe systems and COBOL kind of business language running on them in the 80s, in the 70s and 80s. It is amazing that we still have mainframe systems and COBOL running on them, even though we have very high efficiency database systems like Oracle or MySQL or even unstructured databases and so on. The reason is that these modules have run for so long and they are so stable, their financial system. So Citibank will not risk replacing that. So you get stuck there, right? So there are several reasons which are not only from the engineering point of view. It's finally business, right? And re-engineering an existing software in terms of new platforms and new technologies often is a risk because things might get broken. So you have a system which was based without threading, and that system becomes lower in performance in today's requirement, and you say that I'll go and change it to a multi-threaded model. I'm not talking about language, I'm just talking about a design paradigm. I'll make it a multi-threaded model, I'll use multi-core processors, and I'll give you much better efficiency in that. The customer will simply not agree. Customer is comfortable with what is going on. Customer will say, why bother? I will spend $10,000 more and buy a higher speed CPU. That's it. I'll buy a high speed cache. I will buy high speed main memory, and with that single threaded code, I will manage. Because re-engineering a software product is a high risk as well, right? So legacy, as we'll see that, we in this course we will not be able to discuss enough about that, but handling of legacy is a big issue of software engineering. 70% of the effort you are putting in is to handle legacy, because while on one side only 10% of big projects actually succeed, that is, they complete with the desired requirement, desired quality, in the desired time, with the desired cost, in 10% of cases. But the reality is that the projects that succeed often stay on for a very, very long time, because customers are not willing to reinvest in re-engineering the software, right? So a major effort that goes into software engineering is to how to maintain the legacy, how to progressively rework, progressively re-engineer modules. Okay, you cannot change the whole of it from C to C++, from C to Java, but can you selectively keep on doing modules and keep on doing interfaces so that you can, over a period of couple of years, you will migrate it to a better technology, to a more contemporary platform. So there are different kind of engineering practices that come into that, which we are not talking about so much here. We are talking about this much of a specification, analysis, design, development, and only this much of maintenance. But the reality is this maintenance is this big, which has all of this and has the added issue that you have severe amount of constraints coming from the business side. Does that answer your question to some extent? Understanding is very engineering oriented, is very business oriented. So that is the mindset you'll have to move out from. That when you are an engineer, you are just kind of a pawn in the whole business game. You have to play yourself right to make the business right, not what is right for engineering. You have to do the right engineering for the business. Right.
It's the other way around.
Okay. Yeah. So that makes it kind of, if you cannot get tuned to that will frustrate you in your job. You'll say, no, they are doing all bad maintenance job. But that's where the money is. That's what the dollars are. Money is not in writing very exciting booking code in C++. There's no money in that. Right? In terms of per hour, of course we cannot start anything new, so let me just chat casually. So if you look at the per hour contractual rate of software engineers in US, what skill set earns you one of the highest, what language skill set, programming language skill set earns you the highest amount of dollars? Can you make a guess?
Fortran, I think so. Fortran or COBOL, something like that.
It's COBOL.
Right. It's old.
It's actually something which you have not even heard of. It's JCL. It's called Job Control Language.
Okay, no idea about that. Sir.
A job control language is like a, I mean, like you have scripting language these days, which decides, which task will happen after what. Like scripting
Yes, sir.
language like Perl, right? Which was originally designed for saying that I will make a copy of this directory, I will do backup of this and so on. So earlier days it used to be job control language, JCL. So JCL experts get about $300 to $400 per hour. Whereas being a Java expert, you will get $125 an hour. Right.
Okay, so the more esoteric the language, the higher the.
So, but of course, of course, you don't want to get stuck there, and because there is no finally, software engineering is food for thought. I mean, we are here because there is challenges. There are new things to do, new things to learn. So not many people get stuck there, but that's why often the business has the money, the maintenance, the legacy. Okay. Anyway, it was good giving you some perspective. I'll go into the formals of the models from tomorrow, and all the best for your test in the second half. It will be available on the Moodle. We will start the theory test at 2:15. It will be for 1 hour, 15 minutes, 15 marks, 2:15 to 3:15. We'll have the test. So all the best for that, and let us close here. Bye.
Thank you, sir.
Thank you.
Thank you, sir.